In today's lab, we will study an ideal gas. An ideal gas is made up of randomly moving, non-interacting particles. For an ideal gas in a container of volume V, the ideal gas law holds. This law states that the pressure times the volume is equal to the number of moles times the gas constant times the temperature. Pressure comes from the force of the molecules' collisions with the container walls. It depends on both the molecules' density and their kinetic energy. Temperature is a measure of the average molecular kinetic energy. The average kinetic energy of a molecule is equal to 3/2 times Boltzmann's constant times the temperature. As the temperature increases, the kinetic energy of the molecules also increases. In this lab, we will perform two experiments. In the first experiment, we will measure the pressure of an ideal gas while changing the volume, and in the second experiment, we will measure the pressure while changing the temperature. To set up the pressure sensor, connect it to channel A of the Pasco interface. In Data Studio, select channel A and choose Pressure Sensor Absolute. This will give you the absolute pressure, while the gauge pressure will give you the pressure relative to the atmosphere. The absolute pressure is plotted in kilopascals. When nothing is connected to the pressure sensor, you should measure roughly 100 kilopascals, or the atmospheric pressure. In the first experiment, we will measure the effect of changing the volume on the pressure of an ideal gas at roughly constant temperature. The syringe has a movable plunger that allows us to change the volume of air from 0 to 60 centimeters cubed. We will attach the syringe to the pressure sensor and measure the pressure on the air in the syringe. To attach the syringe to the pressure sensor, press the nozzle of the syringe into the pressure sensor and turn clockwise. The nozzle will snap into place. Let's see what happens to the pressure when we change the volume. As the volume decreases, the pressure increases. As you move the plunger, be sure to hold the syringe at the end, as the heat from your hands will warm up the air in the syringe. Measure the pressure at a range of volumes and record your data in Excel. Then plot the pressure versus 1 over the volume and perform a linear fit on the data. The slope of this line should be equal to nRT, as the pressure is equal to nRT divided by the volume. Based on the initial conditions, calculate an expected value for the slope and compare it to your fitted value. In our next experiment, we will hold the volume of air constant while we change the temperature and again measure the effect on the pressure. We will use a small can that is at constant volume. Attach the can to the pressure sensor and make sure the connection between the can and the sensor is always supported. Boil water using the steam generator. Start this at the beginning of the lab as it may take a while to boil. Only use filtered water in the steam generator. You will measure the temperature of the can using the Fluke thermometer. To use the thermometer, touch the end of the thermometer to the object whose temperature you wish to measure. The last centimeter of the probe should be in contact with the object. Touch the probe to the can in each case to measure the temperature of the can as you are taking pressure data. You will measure the temperature and pressure of the can in 4 scenarios. Use the following order when performing your measurements. After you have taken data at room temperature, lower the can into the boiling water and check that it is fully submerged. As the temperature of the can increases, the pressure will also increase. Wait for the pressure to reach a steady value before removing the can from the boiling water. Repeat the same procedure, measuring the temperature and pressure for the ice water and for the liquid nitrogen. Be sure to measure the temperature of the can in each case. When the nitrogen stops bubbling violently, the can has reached thermal equilibrium with the liquid nitrogen. As you remove the can, do not touch it with your bare skin, as it will cause your skin to freeze. Record your measurements for your pressures and temperatures in Excel, and plot the pressure versus temperature for each case. Then add a linear trend line. The slope should be equal to nR over V, as from the ideal gas law, P is equal to nR over V times T. Calculate an expected value for the slope, and again compare your results.